Hello and welcome to another tutorial. So this is the next part in the series where we are adding Behaviour Tree support to the AI Behaviours package. So with this, same as the earlier sections in this series, if you're looking to be following along as I'm working on this, in the description below there are actually 3 links. The first is a link to the code as it currently stands, so that's the one to grab for if you're wanting to be following along as I'm working on this. The second link is to the code as it is at the end of the video, and the third link is to the completed package. So those are all available for you if you're wanting to make use of those. So what we're going to be focusing on today is getting a few of the remaining areas implemented. So getting in some additional support we need for things like village-based AI, as well as getting in support for Sims-based AI. So we're going to get those up and running. So let's dive on in. So we want to work on the village one first, because it's actually kind of one of the simplest ones, because we've largely got a lot of what we already need up and running. So with it, it's very similar to our ones. I'm bringing the actual prefab for this. So I'm just in the Behaviour Tree one. So the main addition that needs to happen here is we do need to add in a goal for gathering resources, and we'll add in the behavior tree based action for working with resources. But the only additional goal I need to support is I want to add in the one for not FSM actions, for returning home. So we don't have that action implemented yet, but that's actually what I'm going to get set up and running first. So we have already the scripts there for the different actions. So this one is going to be GOAP BT action return home. So we're going to get that up and running. So we'll get it working in this setup first, and then we will build the standalone behavior tree, because we've actually got all the other bits that we need for this, which is really handy. So return home, well, that is based upon our GOAP action, and just GOAP action behavior tree. There we go. We're going to add in the component menu. So make sure we do that first so we don't forget. So this is our BT actions, and BT action return home. Now, similar to what we have done with the other ones, because we want to make sure that we don't miss anything with this, what we're going to do is we're going to get the return home logic that we have here for a state machine based one. So we'll expose these same settings like this. We will also include our required resources and that get home location. So the return home is actually one of the really easy ones to get implemented because we've already got a lot of what we need. So the main thing we need to set up is actually the configuring of the behavior tree. And there's not a lot to it. Because we already automatically keep track of our home location. So that's something where there's not anything further we need to do with that. All we need to do for this is we're going to set up very simple logic. It's very similar to our wander behavior actually. So we add child to the root node. This is just a sequence. And what we're going to do, call it return home, and just as our sequence one like that. So that's good. Now in terms of what it needs to do, pretty straightforward. we can say local root, we add in a child, and this is our standard calculate move location. This is one where we could do this as a parallel set of nodes. There's a few different ways we could do this. I'm going to go for this sort of setup. So our search range, we need to give it our get home location. Now the home location, we don't really expect that to be moving, so we don't need to run this in continuous mode. So the parallel setup, I think, is really good for if it's running in continuous mode. For this kind of setup, we don't really, I think, need it. Because then we just do a local root, add child, and BT action move. And we just make sure we give it our stopping distance. That's all there is to this one. Doesn't really need much at all. It's very, very simple in its setup. So what I can do is I can select this, add in behavior for returning home, like that. So that's good. And I want to then make sure I've created the prefab, because this one we don't have the prefab manually placed in the scene. With this one, what we do after we've created the variant is we actually remove that, and then we select our village and we link the village variant up to it. So that's good. So for this version, pretty straightforward for what we actually need to do. And we can test this out. So if we run this, should get a lot of ones spawned. They're heading off doing the different things. So this one's going in, fetching wood. Bunch will be doing that. Others are grabbing food. Some are grabbing water. Now, the home return won't tend to kick in. The priority is pretty low on that. So, by default, our return home is not going to kick in super frequently. Like, it's there as a kind of a last ditch thing. If an AI gets too far away, it's there to sort of leash them back. But what I could do is our actual gather one, I could temporarily make it that this is actually not going to be able to do anything. I'll just temporarily make it that it doesn't support anything. So then our AIs will wander, and they should hit a point where return home becomes a higher priority for them. So a bunch of them are scattering, heading to sort of different locations. Turn home is not far enough yet for them to start sort of missing it. So that goal is not getting a priority yet. That's okay. Takes a bit for them to be far enough away. And because they're randomly selecting ones, easy for it to be missed. But this one did get far enough away. So they are returning back. And we should, switches back over to wander. So our return home behavior does actually work. So that's good. So this is this version of our actual sort of return home setup and everything. What I want to do is, because that was for the not the standalone one, I want to actually go and set up a standalone behavior tree for this. So we're going to go to our village test scene again. We are going to again bring in, but this time different prefab, and we'll build up our actual standalone BT for this. So bring this in, of our BT standalone, village AI. Now this one, I want to have the RTS one open as well, because the village AI is almost identical. Apart from the addition of that return home behavior, it's no different. So this is our BT standalone base. And that's good. So I will bring over our add component menu as well. Just makes it a little bit simpler. So this is our village AI, and I will bring all of this over because everything that is here, we want the village AI to be able to do. It's exact copy for all of the logic. Now, this does mean that these different AIs, we're reproducing a lot of this same code. That is actually intentional. The reason being is that in a lot of cases, these standalone ones, you wouldn't have them all in the same project. You would have only one of them. So I've tried to keep the standalone base to a bit more of a restricted set of things that are in there. I could have put all of these different ones in the standalone base, and then there's very little that gets implemented, but because it's just something where they aren't ones where we'd have them coexisting typically, I think it makes more sense to keep it split like this. So, okay, that's good so far, but we do need to have this actually work for deciding when to return home. So that's an important thing. So if we take a look at our return home sort of action, the search range, stopping distances, those are all good, but I'm going to go to the return home goal because these distances, I want to bring those over, but I'm going to tend to need to work with them a little bit differently. So we're going to have here header return home like that. So it's going to have still the start distance, the peak, and the reset distance. So all of those are still set up exactly the same. And this logic here for how it decides what it needs to be doing, all of that is still the same. The thing that will be different with the village AI is, so for these ones, gathering was at the beginning of the sort of core behavior setup that we had. For this, because return home is intended as a safety net, it's a, I've gone too far away from home, I'm scared, I want to be returning back. So it actually needs to be further up in the tree. So we're going to set that up here. So this is our return home route. That, and this does get added into our core behaviors like that. We do need to bring over the get home location function. So bring that over so everything's not grumpy at us. And that changes to current Blackboard. So that's good. So the big thing that sort of changes here, though, is we've added in that return route. We've got the actual sort of behavior there for it. But similar to what we did with the can gather, we actually want to add in a couple of decorators for it. So we do want a similar sort of thing with a cooldown. We'll look at that in a moment, and we'll have a should return home. Will be return home. Now I do want a little bit of a cooldown on this because I think that's something where we don't want to continually be checking it. And I think after we've returned home for a bit, we want to sort of pause it for a time. Just going to set this up here. So we will have serialize field float. So we'll say 1 for this. I'm just going to update these to be consistent. so used to from C++ having to actually put in the point 0 with everything. So I'm trying to be consistent. Even though I do appreciate in C# being able to use the abbreviated syntax. So that's good. So we'll have a max return home cooldown. And we might say that that's 5 seconds. So that's good. So now we can implement this should return home function. So its job is to, similar to what the can gather function did, its job is to make the decision of, is it appropriate for us to actually return home? So what I'm going to do is we'll set this up here. So I want to have a bool should return home in delta time. Now what we want to check here is, okay, let's get our home location to start off with. So we get the home location. Now with the GOAP-based setup, this is actually a little bit easier to work with because we know sort of whether we're currently doing that action for returning home, things like that. Should return home, that function doesn't really know that. So we actually have to store a little bit of info for it to be able to do that. So I'm going to have a nullable bool here for is returning home. And I will bring that up to the top so it's in a consistent place. So that's good. So what we want to do is we want to check, firstly, okay, is that home location valid? And in this case, we'll check if it's actually invalid. So if that is common core constants and an invalid vector3 position, we just always return false. So we shouldn't ever return, try to do the return home in that case. And we'll also just make our default return false. So, okay, it's good. If we're at this point, we know we have a valid location. We want to get our current location. So our current location, we can get that from our blackboard. So that's our current blackboard. And what we do is we get a vector3 and we want our common core names and we want our current location. So that's good. Now that always has to be valid. So, okay, current location, we want to check how far are we from that. So we're going to say distance to home squared. That is equal to our home location minus current location, and we square it. So if that distance is less than our start distance, so the missing home start distance, so if it's less than that, well, that is returning home. We can reset it to null and we can return false because we're too close to, like, we're not started missing home yet, so we don't want to actually take any action. Alternatively, if the distance to home squared, if that is greater than or equal to our missing home peaks distance squared, then it's actually really easy because in that case, we absolutely need to be returning home. So that goes to true and we return true. Otherwise, the scenario that we face is, and that needs to be else if. In this scenario, we could be currently returning home, but we are less than that peak distance because as soon as we go beyond that peak distance, we'll start trying to. So what I would be doing here is if returning home is set, and that's the only scenario where we care about this, if that distance to home squared, if we have gotten less than our reset distance, So if we are less than missing home reset distance squared, then what we're going to do is say we'll set the is returning home to null. We can just let it fall through and return false. Otherwise, what we do is we return the returning home dot value, which should be true. So that's good. So we won't actually start returning until we hit that peaks distance. So that looks good. We should be able to set this up on our AI now. So we can add our standalone behavior tree for the village. We need to link up point of interest stuff. So that goes to the simple AI character and set look target. The rest of that is all good. We can let it create our variant, remove this, and then we update the village to be spawning that one. So let's save that and we'll test this out. So it spawned a bunch of the AIs. We can see that they're not trying to return home, they are gathering resources. That's good, the gather logic is happening. We've got ones gathering different types of resources. So some are getting food, a bunch are getting water, a few are heading back to the storage now. So that seems to be working nicely. And if we move over in the scene, we actually see that they are wandering around, just our little AIs doing their thing. That's good. A lot of ones went and grabbed water. But they're continuing to go and do that logic, and then they will alternate at times. Once they're finished gathering, they'll generally go and wander for a bit because they'll be in the cooldown. Some of the ones, so like if this one is just there going and trying to do the storage, so that's good. So they are generally working the way we would want them to. So that's great. So, okay, we've got our standalone behavior up and running for that. So the final set of stuff we want to get up and running is for our sim style AIs. So we've gotten a lot of the other ones all good to go, but this is the remaining one that we want to get set up. So it's going to have all of those default behaviors, but it's also going to get the goal for interacting with things. It's going to have use interactable as a goal. We need to link that up for it to be able to decide if it wants to interact. That, I believe, is on our GOAP brain wrapper. Get user interactable desire. There we go. So that's hooked up. But we need to set up the systems for the actual Sims one. So what that needs is us being able to select and use an interaction. So we're going to create a GOAP BT action. And this is going to be the interact. So this is our, well, actually, I'll follow the naming convention that we used for the others. So this is use interactable. Think about that. So we'll set up this, we'll set up the two nodes that we need for this. Don't know why Visual Studio is deciding to reopen. Sometimes it seems to get really confused with stuff. So I'm just going to save and close those. Should be fine. So, okay. we've got our use interactable. I'll close everything else. And then what I'm going to do is create our nodes for this. So we want a BT action, and this one will be select interaction. And then we will have a one for actually using the one. We have a BT action, use interactable. Good. So I want to open up those two as well, because they're ones that we need to be updating. So let's get these behaviors for sort of selecting an interactable and everything working first. So they're similar to the state machine one, but because of the sequencing of stuff, these do work a little bit differently, but that's okay. So these are based off of our action node base, like that. Let it implement everything. Very familiar territory by this point. That's good. So this is select interaction. So that's good. Now this, in our state machine based one, there is a functor. We do still need to have a similar setup here. So we're going to have a system func that takes in a game object, but then also returns a system.tuple. So a handy little thing for just being able to smush together seconds of different data. So it's going to take our smart object and our base interaction. So this is our select interaction function. Then we have our constructor. Oops. So select interaction. Now what this is going to do is it does need to take that in as a parameter. That's sort of the first one it needs. And then, similar to what we have for all of our other ones, we take in our display name, like that. We do our usual logic, so checking that it is not null or empty, and then just actually storing it. Wow, it really got the wrong name with that. But we do store the select interaction function. So that's good. So then in the node logic here, so first thing I want to do is essentially put the blackboard in a known safe state. So our linked blackboard, I want to set, and I want to set our common core names and our two interaction ones here. So that is a smart object of null, whereas then the other one, so this is our interaction type. This is a base interaction. So that's good. So we always reset that. Then we will check, just in case our select interaction function is null. If it is, then we're going to fail out, because without that we can't do anything. Then, if that worked, I'm going to attempt to find an interaction. So what that needs to do is we'll actually invoke that function. So we run our select interaction function, passing in self. Now, if that interaction is null, or if the contents of it are null. So if item 1 is null, or item 2 is null, then there is nothing useful that we can do. We need to fail out. So we just return failed in that case. So, okay, if we then get to this point, we know that we have successfully found an interaction that we're going to be able to perform. So our target smart object is in our interaction item 1, and our target interaction, that is actually in item 2. So strictly don't need to be extracting them out of the tuple. The reason I do that is because it just makes the code more readable, and that's always a good thing. Because then the code is fairly self-explanatory when I say, well, okay, well, if target interaction cannot lock the interaction for us, then again, we set status, turn value, and we failed. Otherwise, if we've gotten past that point, we can actually populate the blackboard because these are valid. So we have our target SO, have our target interaction. So both of those are valid, and we can return and do our set status return. But in this case, we have succeeded. So that's good. That's all we need for the select interactable. The next one we need to get up and running is our use interactable. So that is going to follow some similarity. So with our use interactable, that again comes off of our action node base. Implement all of the defaults. Do our standard cleanup. Use interactable. Like that. We set up our constructor. We'll have our display name and be able to do the usual checking that we do. The display name is equal to that, so that's good. Now this does need to keep track of if we have finished the interaction. So I'm going to put a bool here. The B has finished interaction. That'll default to false. So it's useful for us to be keeping track of it. What I then want to do is we actually want to do a bunch of logic in our on enter. So we're going to do a protected override for on enter. So it can run the base. So first thing we do is we reset this to false. Then I want to attempt to retrieve the details about that interaction. So our smart object for our target game object is null. So I want to do a try get on our linked blackboard. Try get, and what we're trying to retrieve is our common core names and our interaction smart object like that. That goes out to the target SO. Oops, that should be SO there. And defaults to null. Now, if that failed, so if target SO is null, then that's no good. We've failed, so we're going to actually set our last status to failed, like that, because we can't continue running at that point. So we will also do a return. What I will then try and do is we want to retrieve our base interaction, because that's the second part of what we need to be doing. So our target interaction is null. So if that's the case, then what I'm going to do, and this is a bit of a different way of actually doing this. We won't have much in the tick logic. We'll see why in a moment. Because what I do is do another linked blackboard, another try get, similar to before, names and interaction type, target interaction and null, like that. And again, we'll do some null checking here. So if target interaction is null, then we fail and we return. So that's good. Now, if we are failing and returning at either of these points, I will null things out. So we do have this same logic here, nulling things out. So what I will do is in both of these cases, null them out like that. So that's good. So we're doing all of our setup at the beginning for locking this when at the first sort of instance we enter it. That's because what we will do is, firstly, our last status is going to be in progress. And then what we will do here is target interaction, perform, get self, then we have base interaction, in interaction. So we're just linking up a little function here that what it's going to do is this function gets run when it's finished. So we can unlock it immediately at that point. And what we can then also do is clear out any of these. And we set that has finished to true. So that simplifies significantly our tick logic. For one thing, if our status is actually already that we failed, then I'm just going to return false immediately. There's nothing fancy we need or want to do in that case. Otherwise, our status depends upon whether B has finished interaction is set or not. So what I could do is last status, if we have finished the interaction, then we're succeeded. Otherwise, it's in progress. And then we just return. Now with this, if we have done either of those, we return true. So it makes our tick logic significantly simpler. And this can be a handy way of doing things. When you want to have a whole bunch of key important initial setup stuff that must run, and then using the onEnter for that is a really good usage of it. And then in the tick, all we do is just actually check to see, is it actually finished? So it just makes for a bit of a more robust way of working with things. So that's good. So then here, this is our GOAP action and our GOAP action, there it is. So we make sure we populate our add component menu. So AI GOAP BT actions. And this is BT action use interactable, like that. So that's good. We do want to grab stuff from our state machine based one because there is, unsurprisingly, a lot of overlap. And again, this is about us making sure it's consistent. So we just bring over all of the things like the cost calculation, as well as the getting of the resources and sort of these helpers. Now this does have stuff for resetting the state machine. We'll look and see, what of that we actually need to use. That's good. Let it implement the one function that it needs to. So in terms of sort of what these different ones are doing, the get interactable location, no changes needed for that. Our select interaction function, all of that can stay the same. We will need to handle resetting of the behavior tree just as in case it gets interrupted. So what I'm going to do is have a protected override. And we have our behavior tree reset. So what we do for the reset of that, if we take a look at what we did here, it's actually going to be the same. So the same logic, we do that here as well. We just need to go and we make sure we clear out the target object if it's set. So we're just going and checking, okay, is it there? Do we need to forcibly unlock it? This is handy for if something is interrupting the particular behavior. So it just ensures we properly clean things up, which is always good. So with that in mind, we can configure the behavior tree. And reasonably straightforward in terms of what we need to do. So our local root that we add in is we're going to add child to root. This makes sense, again, for being another sequence node. So we have our sequence node for our use interactable, like that, and cast it like that as well. So that's good. Then in terms of what we need to add to that, well, get child added to it for actually selecting the interactable. So that's our action select interaction. Unsurprisingly, we pass in our select interaction function. Once we've selected an interaction, we need to calculate the move location. So we add, and we add our action to calculate a move location. We need to make sure we give it our valid search range. We need to get our interaction location function like that. And then finally, we need to make sure it moves to it. We give it our stopping distance, so that's good. And then to actually use it, so we add child and a new BT action, use, and with that, we don't really need to actually provide anything extra. So that's good. That should give us behavior that can actually go and use an interactable. So if I select this, I can add in our BT action for using an interactable. We need to link up the actual to the brain for doing that. So that's good. I will also, because this is a very small environment, just drop the wander range to 1 to 5. So that's good. Let's create that prefab variant and just save this. So let's test that out. So no errors. They're heading over to the bookshelf. They're interacting with that at the moment. Doing the same with the other bookshelf. So at the moment, they're definitely prioritizing just sort of the bookshelves, but part of that is down to it being random, but it's heading over to the microwave. So that's good. We've got our sim style one working there. So the final bit we want to get going for the sim style one is having this actually work standalone. So that's the remaining one to have happen. So if we head to our standalone one for the sim style, we will bring in the corresponding prefab, rename that. So we need to set up a standalone behavior tree for this. So this is going to be our BT standalone Sims AI. It will inherit from our standalone base, like that. Now this is one where with our standalone base, we currently, if we go and take a look at what we have in it, because that's actually really important, we've got that default interactable search range, which it has been sort of complaining at us about for a while because we weren't using it. And that's because we want to actually bring over, but we will modify them a little bit, the functions from our GOAP brain wrapper for actually working with points of interest. Sorry, not points of interest, with interactables. Because we have this get use interactable desire, but we also need to be able to perform the interactions. So I'm going to bring this whole region over for now, but we will actually modify how we work with these. So I'm bringing that whole block from the GOAP brain wrapper over to the end of our standalone base. So that for now is fine, but how we work with it in the standalone ones will actually be different. So that's good. In terms of sort of the core logic that the one needs to have here, we want a lot of similarity with our FPS one. So our FPS one is probably a good starting point. Now we don't want chase logic, but we do want wander and idle and all of the movement stuff. So I'm going to bring those over. So those come over to our Sims AI one. Implement things like that. So those are a bunch of common settings we're going to have. Behavior tree configuration, we will do Blackboard and Brain. There's nothing that we need to be configuring there. So, okay, that's good. I will bring over a bunch of stuff from the configuring of the behavior tree, just because a lot of it is similar. So if we bring that over, the main one we don't have is we don't have chase. But wander, idle, all of those, we do actually want to keep all of that logic. Then the only remaining thing is our wander location. That's good. So, okay, good so far. The bits that we've brought over are going to work, but we need to bring over logic then for our actual sim style stuff. So we will still be modifying some things in the standalone base. But in terms of what we need to bring over, so okay, search range, all of those ones we do actually already have. There's no sim specific settings that we need to bring over in that regard. So let's actually just set up the behavior, because that will help us identify the things that we do need to bring over. So this is our interact root. And we're adding to our core behaviors root with this. So that's good. So it is still a flow node of sequence. All of that stays exactly the same. Similar to what I did with other ones, I will add in a cooldown to the interactions so that it's not doing them all the time. So I will add in decorator, and we'll have a cooldown. So min interact cooldown and a max interact cooldown. Again, just so that they're doing other things. Set this up here, interact. It's a big thing we find when we switch from having stuff as a with the GOAP wrapping to something that's standalone. Because it's a standalone one, we need to find ways of giving it other things to actually do. So that's sort of an important part of what we're trying to do with this. So, okay. Now, obviously, there's things that we need to implement here. Now, the getting of the interaction location is going to be one. We want to also add in a one here, another decorator, following the same pattern we did for other ones of our function decorator. Can interact. Just like that. So, okay. So a bunch of different things we need to set up. So wandering, straightforward. Can interact. Okay, well, can interact. It does get our delta time as part of that. Not that we use it, but we get it. So we already actually have in our base the ability to get the use interactable desire. Now at the moment, this passes it back via a callback. So I'm going to change this to actually just return it. So we will just return that. A fixed value like that. So that's good. Because what we can then do here is, okay, well, I want to get use interactable desire, pass in myself. We need to pass in this case, I just want an unlimited range. So in this case, I'll say min desire to interact, or min interaction desire required. So what we have here, have a range like that. Want it all in the one line because it makes it a little bit nicer. So the min desire it needs to be for it to interact. So let's say 0.1. So that's good. So can interact as long as the desire is, we'll say greater than or equal to that, then it can actually perform an interaction. So that's good. We've still got a couple of other bits of logic that we don't actually have set up. So one is that get interaction location. That actually can just come straight across. Doesn't need to change. Similar logic to what we do with the get wander location. We just need to change the blackboard reference. So that's good. We can handle that side of it. So now it is just down to these bits of logic for actually selecting the interaction. So, okay, for selecting the interaction, for that, we, in our one here, we do actually have a wrapper. We do want to still largely follow that, and we kind of have to have it look similar, but because we have everything in the sort of standalone base for the function that it's going to be calling, because I want the nodes to be able to work for, the GOAP-based ones and also standalone. So those variations I'm going to handle that here. So before, what this would do is this would run an event that had to be linked up. Whereas what I will actually do is I'm going to do select random interaction, and it actually takes in the exact same parameters. So it doesn't need to be any different. We just do that exact logic. And that gives us our standalone one that can do those interactions. We need to make sure that we didn't yet. So we add component menu. So AI standalone. So we just make sure we give these proper names, just keeps it nice and easy to identify everything. This is Behaviour Tree Sims AI. So that's good. Let's attach that behavior to this prefab. Standalone, Sims one. We need to link up a bit. So simple AI character and set look target. But that's good. That's everything we have to link up. We make sure we create that prefab variant. Like that. So let's save and test that out. So it is going and performing an interaction. Once it's done, this will go on cooldown. And so it's just idling because the wander didn't pick a valid location. Now it's going and doing another interaction. Idling again. So the wander, what we likely need to do is drop our ranges. And I will update the prefabs here as well. That way when it drops into wander, it should have a better chance of actually picking a valid location. Using it. So made food. This time it didn't manage to pick a wander location, but should have at least a better chance of doing it. Depends, because it is fully random and it is random based upon... Yeah, so there we go. It did wander for a little bit. So that's good. We have it wander around, have it interacting with stuff. We do want to, because we've got our interactables, that cleanup logic that we did here, we do need to do this same sort of cleanup logic. So we actually have that same on behavior tree reset function, and I'm just going to bring this over. The reason being, this wouldn't cause an issue with just a single AI generally. But if we have multiple ones, then we need to be able to have them properly clean up. So that's good. We have our different sets of behaviors up and running, and we have our behavior tree based versions that sit within the GOAP framework, and we also have standalone versions. Standalone versions are a really good illustration of sort of some of those additional nodes like cooldowns and things like that. They also show, a very different sort of behavior. The GOAP-based ones tend to be a little bit sort of slower and more deliberate in what they're selecting to do because there is that more nuanced prioritizing. Whereas the standalone versions are very much do this, oh, I can't do that, okay, do this, or do this, then this, then this, then this. So it changes sort of the way we have to structure things, and we end up with much simpler criteria for deciding what it should be doing. So either one, though, is a perfectly valid way of actually working with it. But dive on in and experiment with this. There are going to be further things that I do in terms of updates to this. I do have plans in particular with things like the debugger. There's going to be systems that I'm also adding in terms of making the interactables and other aspects like that more generic, so that those will actually sit down at the core level of the GOAP system. So that's going to happen as I refactor those systems over time. but that will be a little bit before those are up and running. And similar to what I did with having the standalone behavior trees, I do also want to have standalone versions of the finite state machines. But at least initially, the next few updates that I want to be doing to this, I want to try and avoid anything that would be, API breaking for people. Thanks, folks. Hope you found the video interesting and helpful. If you have, check and like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, there are 3 links in the description below. The first link is to the code as it was at the start of this project. The second link is to the code as it is now. And the third link is to the completed package that has everything there, and depending upon when you're accessing that package relative to this video, might also have additional stuff, so some of the APIs, things like that might have changed. If so, there'll be details there in the change notes for it. But that code, you can freely use it in any of your own projects, commercial, non-commercial ones. If you've got any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time,